Do you know the best way to improve your procedural skills? It is solving paper 1. Let's dive in.
Question 1. The first and fifth terms of an arithmetic sequence are 36 and 12 respectively. Find the 13th term of this arithmetic sequence. It's given that the first, a sub 1 is 36 and a sub 5, which is fifth terms, is 12. And I know that a sub 5 equals a sub 1 plus 5 minus 1 times the common distance. If you plug in a sub 5, which is 12, and a sub 1, 36, plus 4 times d, and subtract 36 from the both sides, we will have minus 24 equals 4 times d, and d equals minus 6. And we're gonna look for the 13th term. A sub 13 equals a sub 1 plus 13 minus 1 times d, right? Equals a sub 1 36 plus 12 times minus 6. From here, we're gonna get 36 minus 72 equals minus 36. At the second question, the sum of the first n terms of this arithmetic sequence is 0. Find the value of n. So how we're gonna find the sum of the first n terms? We call it Sn. It is n divided by 2 times a sub 1 plus a sub n, or you can write a sub 1 plus n minus 1 times b. We're gonna write a sub 1, it is 36, and we found the common distance, it is minus 6. Just simplify here and it will be equal to 0. From here we can say that the expression in the parentheses will be 0, which is 72. If we distribute minus 6 into the parentheses, 6n plus 6 equals 0, right? 6n will be 78 and n equals 13. Question 2. Given that x greater than 7, show that there is an expression here. Okay, it's given that x divided by x squared minus 8x plus 7 times x squared minus 1 divided by x plus 1. Okay, and we can factorize these expressions. For example, that the denominator x squared minus 8x plus 7, we can write it, I know it. Here, if you want to factorize this expression, I know that the factors of x squared is x, and I'm gonna write the factors of 7, minus 7 and minus 1, because when we cross product and sum of these two expression, it will give us 8 say, x. From here you can write x minus 7 times x minus 1, which is factors of this expression, times, and I will again factorize x squared minus 1. It is x plus 1 times x minus 1 and divided by x plus 1, right? We can cancel x plus 1 because I know that it is greater than 7. And we can also cancel x minus 1. In this case, it will be x divided by x minus 7. Ins or otherwise, so there is an expression in here, it's logarithm. We can write it logarithm base 2 of x times x squared minus 1 minus 1. Yeah, equal logarithm base 2, this expression. Yeah, for example, we can write instead of 1, the logarithm base 2. I will write it, or you can show it that it equals logarithm base 2 or of 2. And since this is the property of the logarithm, which is if there is logarithm, uh, let's say a minus logarithm b, it equals logarithm a divided by b. I will apply this attribute. Logarithm base 2 of x times x squared minus 1 divided by 2 is coming from here, right? Equals logarithm base 2 of the same, or you can write the factors of this expression. It is x minus 7 times x minus 1 times x plus 1. From here, you can say that the base of two logarithms equal each other. I will just write an equation between these expressions. X times, I'm also, yeah, this one, divided by 2, x minus 7 times x minus 1 times x plus 1. We can also cancel x squared minus 1, and when you multiply it to the both sides by 2, you will see that x equals to x minus 14. From here, you can see that x equals 14. Question 3. A line with equation y equals minus 3x plus 9 intersects the axis at the points P and Q. Parabola of the form y equals ax squared plus c, where ac is an integer, also passed through the points P and Q. This is shown in the following diagram. Write down the value of c and find the value of a. Yeah. So we know that the parabola is passed through also P and Q. We can also plug in these points into this equation. It's given that the parabola expression. So I will just replace y with, for example, 9 and replace 6 with 0. In this case, it will the equation you can write 9 equals a times 0 squared plus c. From here, you can say that c equals 9. If you also plug in this the point q into the equation, and you're gonna replace y with 0, uh, a times, and you're gonna replace 6 with 3 square, and we found c is 9. It is 0 equals 9 times a plus 9, and subtracts 9 from the both sides. 9a equals minus 9, and a equals minus 1. In this case, the expression of the parabola is minus 6 squared plus 9. Okay, find the area of the shaded region. So we're gonna apply the integral. It's going from 0 to 3, let's say from 0 to 3 here. And I know that the graph of the parabola is at the up of the line. So we will subtract the line expression from the parabola expression. You can write first the parabola minus 6 squared plus 9 minus the expression of the line which is minus 3x plus 9. Okay, and there is the x here. And when we simplify this integral, minus 6 squared plus 9 plus 3x minus 9, we can cancel 9 in here, and do not forget to write the x from 0 to 3 minus 6 squared plus 3x, the x. And I know that the integral of the x squared is minus x to the power of 3 to divide it by 3. I will write in here. X to the power of 3, we will divide it to the power of x plus the integral of 3x. It is 3 times x squared divided by, again, power of x. And our limits is from 0 to 3. We will just plug in 3 first into the expression. It will be minus 3 to the power of 3 divided by 3 plus 3 times 3 squared divided by 2. And I know that from here we will get minus 9 plus, let's say, 27 over 2. And and it is 27 minus 18 divided by 2 will give us 9 over 2. Yeah. Question 4 is not seen clear, but I will write it again. For x is a real number. The functions f and g are defined by f of x equals, I'm writing again, minus 6 squared plus 4x plus p, and g of x equals x squared plus qx minus 1, where p and q are non-zero constants. The graph of f has a vertex at a vertex, and the graph of g has a vertex at b. Points A and B lie on the line y equals 2x minus 1. Show that P equals minus 1 and find the value of Q. Okay, and let's start first with f of x has a vertex at A. What's the vertex point? And the vertex point, if we call it the point V, r and k. I know it r equals minus 4, which is the coefficient of x. I mean, minus the coefficient of x divided by 2 times the leading coefficient in here, minus 1. From here, you can say that r equals minus 4 over minus 2 will give us 2. And so if it is we know what here A, and if the point A is passed throughout the line to x minus 1, we can plug into this equation. In this case, y equals 2 times 2 minus 1 will give us 3, meaning the point A equals 3, 2, or 2, 3, yeah. So we can also plug in this point into the function f because f of 2 equals 3, and the expression of f will be minus 2 square plus 4 times 2 plus p equals 3. Minus 4 plus 8 plus p equals 3. 4 plus p equals 3. From here, p equals minus 1. The second question, find the value of q. Okay. We can do the same, for example, for the point B, again, R and K, and I know that R equals minus the coefficient of X in here, Q, divided by the leading coefficient of G is 1. We will divide it by 2. This is the point R. We can also plug in this point into the line equation, and Y equals 2 times minus Q over 2 minus 1, which will give us the value of y minus q minus 1. We can also plug in this into this function because the point in this case b will be minus q over 2 and minus q minus 1. So g of minus q over 2 will give us minus q minus 1. When we plug in this minus q over 2, right? It is q square over 4 because I write the square of the expression times q times x, which is in here, minus q over 2, right? Minus 1 equals minus q minus 1. We can cancel minus 1 in here. So minus q square over 4 minus q square over 2 here equals minus q. Let's find the common factor of 4, and it will give us minus q square over 4 equals minus q. From here you can say that we can cancel the negative sign and also write q square equals 4q. Q is okay. From here I know that q is non-zero, right? Q, yeah, these are non-zero constants, so q is 4 if you cancel one of the q. Yeah. Question 5. The first four terms of the Maclaurin series expansion of 1 minus 6 to the power of minus 4, 1 plus ax plus bx square plus 20x cube. Ab is a positive integer. Show that a equals 4 and find the value of b. So to find the Maclaurin series, we're gonna need the derivative of this expression. If we call, for example, f of x equals 1 minus 6 to the power of minus 4, and we can write the first derivative of this function. It will be minus 4 times 1 minus 6 to the power of minus 5. We are decreasing by 1. And do not forget to write the derivative of the inside of the parentheses. It's going to be minus 1 from chain rule. In this case, will be 4 times 1 minus 6 to the power of minus 5. What's the second derivative of this function? And we again write the power of this expression to the down, and it will be minus 20 times 1 minus 6 to the power of minus 6, but I will multiply it by the derivative of this 1 minus 6 will be minus 1. So 20 times 1 minus 6 to the power of minus 6. Again, f to the power of 3, I mean the third derivative of f, will be 20 times minus 6 times 1 minus 6 to the power of minus 7 times the derivative of the inside of parenthesis minus 1 will be 120 times 1 minus 6 to the power of minus 7. But when we write, for example, the Maclaurin series, we will just plug in 0 into these expressions, okay? For example, the first derivative of f at the point 0 is 4 because we are just plugging 0 in here. And the second derivative of f at the point 0 will be 20, right? And the third derivative of f at the point 0 will be 120. So what is Maclaurin series? 1 minus 6 to the power of minus 4 equals, by the way, f of 0 will be 1 because you plug in 0 in here. And 1, which is f of 0, plus the first derivative we found is 4 times 6 divided by 1 factorial, plus you will write the second derivative we found 20, you will multiply it by x squared and divide it by 2 factorial, plus the third derivative at the point 0 is 120, and you will multiply it by x to the power of 3 and divide it by 3 factorial, okay? This is the Maclaurin series. From here you can write 1 plus 4x plus 10x squared because 2 factorial is 2 and 3 factorial is 6, right? It's gonna be 20 times x to the power of 3. So we found that a is the coefficient of x, it is 4, and b is coefficient of x squared, it is 10. The second question, a car was purchased 4 years ago. The car depreciated in value by 10% each year. The value of the car today is $1,000. Using the result of part A, estimate the value of the car 4 years ago. Okay, we know that the car depreciated in value, right? We don't know the value of the car at the beginning. Let's call it the value of the car X at that time. But the value of that car is depreciated 10% every year, meaning 0.1 decrease, right? How many years pass? It is 4 years. And the current value of the car is now $1,000, right? This is our expression, and you can simplify it like x times zero point 0.9 to the power of 4 equals, or you don't need to write it, or yeah. In this case, you will just write x equals 1,000 times 1 minus zero point 0.1 to the power of minus 4, right? Because we divide to the both sides this expression. Meaning we know that the expression in here, when the power is minus 4, you can just actually replace 6 with 0 0.1. In this case, x will be 1,000 times, in parentheses, you can write 1 plus 4 times 0 0.1 plus 10 times the square of 0.1, it will be 0 0.01 plus 20 times the power of the third power of 0.1 will be 0 0.001. Yeah, we can also distribute 1000 into parentheses. You will see that 1000 plus 400 plus is gonna be, what is that? 100 plus 20, right? Yeah, because, yeah, which is 1520. Question 6. A linear system of equations given by, here is the equations. Find the value of alpha and the value of beta, where these are the integer numbers, for which the system has an infinite number of solutions. Okay, I first would like to cancel that. When you find the sum of these two equations, it is 3x plus 2y equals 18. At the same time, you can write x equals from the first equation 4 plus z, okay? And also, we know that the third equation is x plus 2y plus alpha z equals beta. When you, for example, subtract from the first equation to the second equation, you will find that 2x minus alpha z equals 18 minus beta. We found that x equals 4 plus z. In this case, we can just replace x with 4 plus z, right? You can also write alpha like this, the symbol, meaning 8 plus 2z minus alpha times z equals 18 minus beta. When you combine the values of z, you will see, by the way, you can subtract 8 from the both sides. You will see that z times 2 minus alpha equals 10 minus beta. If this equation has an infinite number of solutions, you can say that 2 minus alpha equals 0 and 10 minus beta equals 0 to make this equation independent from the z. In this case, alpha will be 2 and beta will be 10. Question 7. Consider the differential equation dy over dx equals y square times cosine square x. The solutions to this differential equation can be expressed in the form, here is the form, where alpha and a and b are constants such that a is integer and b is real number. Okay, first try to solve this differential equation. To do that, I will write all together the values of y and the values of x, or the expressions of x and y. So I am just dividing to the both side y square and multiplying to the both side by dx will give us dy over y square equals cosine square of x times dx. From here you can find the integral for the both sides. What's the integral of the 1 over y square? And I know that you can write y to the power of minus 2 in this case. Um, I will write instead of cosine square, um, you know that the double angle formula, which is cosine 2x equals 2 times cosine square x minus 1. If you write, try to find the cosine square x, you will see that cosine 2x plus 1 divided by 2. In this case, you can use this formula, cosine 2x plus 1 divided by 2. Okay, now I will write the integral of the y to the power of minus 2 will be 1 minus y to the power of minus 1, or you can just write minus 1 divided by y, right? Yeah. Equal, uh, you can write 1 over 2 out of the parentheses and try to find the integral of this expression. The integral of cosine 2x will be sine 2x divided by 2 because it will come to the derivative of 2x, and I will eliminate this, plus x. Yeah. And do not forget to write the constant value of c. That's it, I guess, right? Yeah. So when you simplify this expression or equation, you will see that sine 2x divided by 4 plus x over 2. You can also write directly the constant value of c because it's not going to change anything if you multiply it by any real value. It will again will be c. And minus 1 over y equals, I will write the common multiple all of the denominator. I know what it is for because, and sine 2x plus 2x. I will write here c directly divided by 4. Yeah. And from here you can say that when you make a cross product or write directly y, you will see that minus 4 divided by this numerator, sine 2x plus 2x plus c, right? Yeah. In this case, the value of a is minus 4. Okay. So how are we going to find the value of b at the next question? Given that y equal 1 and 1 x equals pi over 2, find the value of b. Okay, I know the values of x and y. I will just plug in, for example, the value of y, it is 1, and the value of x is pi over 2. In this case, here is going to be sine pi plus pi plus c, right? Yeah. And simplify this equation. 1 equals minus 4 divided by, now that sine pi is 0, pi plus c. Pi plus c will be minus 4, and c equals minus 4 minus p, right? Yeah. In this case, we found c, which is b in that equation, and b is minus 4 minus pi. Question 8, show that sine 3 theta equals 3 sine theta minus 4 times sine to the power of 3 theta. I will write, instead of sine 3 theta, 2 theta plus theta. And if you apply the property of the uh, compound angle attribute, it will be sine 2 theta times cosine theta plus sine theta times cosine 2 theta. And I know that at the question it is all with sine theta. There is no cosine theta, so I will change cosine theta to the sine theta if it is possible. And when you apply the double angle attribute to the sine 2 theta, you will see that 2 times sine theta times cosine theta times cosine theta plus sine theta. And I know that at the double angle of cosine 2 theta, you can write 1 minus 2 times sine square theta. And here is 2 times sine theta times cosine square theta, right? And you can also distribute sine theta into this parenthesis, sine theta minus 2 times sine to the power of 3 theta. I will replace cosine square theta with 1 minus sine square theta, because 1 plus sine square theta, sine plus cosine square will be 1, plus this one, and again simplify. 2 times sine theta minus sine to the power of 3 theta plus sine theta minus 2 times sine to the power of 3 theta. And combine the like terms. Here is gonna be, here is 2, right? Yeah. And this one is gonna be 3 times sine theta minus 4 times sine to the power of 3 theta, okay? And the second question is, describe a sequence of transformations that maps the graph of y, sine theta onto the graph of y, okay. I will first start, what is this? Y equals 6 times sine theta plus pi over 6 minus 8 times sine to the power of 3 theta plus pi over 6, right? And the previous question, we found something similar to that. For example, from A, you can say the 2, if you multiply by 2 to both sides of this equation, you will see that 2 times sine 3 theta will give us 6 sine theta minus 8 times sine to the power of 3 theta, right? From here, yeah. And this expression given the question B, it's similar to that. In this case, I can, for example, say that 2 times sine, let's say 3 times in parentheses theta plus pi over 6 will give us y. I can write directly, actually, yeah. When you replace theta with theta plus pi over 6, yeah. So how we gonna get this function? If you apply some transformation to the function sine theta here. By the way, yeah, okay. I would like to write, because it can be confusing. There is 2y in the question. I will write directly this one. So first, I will apply, let's say, the horizontal stretching is gonna be 3 theta, right? This is horizontal stretch by scale factor 1 over 3. Yeah, wait. And the second one will be horizontal translation again, pi over 6 to the left. And the last step will be uh, vertical stretch with a scale factor 2, right? Let's write it. And this is vertical stretch with a scale factor 2. Yeah, that's it. Question 9. The function f has a derivative given by derivative of f equals 3x squared plus 12x minus 15. The graph of fy has horizontal tangents at the points where x equals a and x equals b. A is less than b. Find the value of a and the value of b. If this point is horizontal tangents, and meaning that uh, the derivative of this function will be 0 at this point, right? At the point A and the point B. So when you find the factors of this expression, you will see that the factors of 3x squared will be 3x and x. And if you find the factors of minus 15, like um, minus 3 and 5, because I know that when we cross product 15x minus 3x will give us 12x. In this case, you can write the expression to the factor 3x minus 3 times x plus 5 will give us 0. From here, you can see that 3x minus 3 equals 0, meaning x equals 1, and x plus 5 equals 0, x equals minus 5. The point A is minus 5 and B is 1. Okay, yeah. The following theorem shows three intervals along the x-axis defined by a and b. The sign of the first derivative of f is shown in each interval. State with a reason whether there is a local maximum point or a local minimum point on the graph of f at x equals a. I know that a is minus 5 and b is 1. This is the sign table of the first derivative, and if you check for the point a, you see that this is going from increasing to decreasing at the point minus 5. Because of this, we can say that the point of A is a local maximum, x equals minus 5, uh, or you can say there is a local maximum at x equals minus 5, since at this point, f is changing from increasing to decreasing. Yeah, and the second derivative of f at x equals c is 0. Find the value of c. So how are we going to find the second derivative of this is going to be the question C. The second derivative of x is, I know that the first derivative is given in the question, and I will just find the derivative of this expression. It's going to be 6x plus 12, right? Yeah. And when you equate this to the 0, you will see that x equals minus 2. In this case, the value of c is minus 2. Okay. At the next question, the following diagram shows two intervals along the x-axis defined by c. The sign of the second derivative is shown in each interval. Yeah. State with a reason whether there is a point of inflection on the graph of f at x equals c. So at the left of this point, you see that this is the concave one. The meaning of the second derivative actually it's give us this whether concave up or down. And the right of this point, since the sign is positive, it give us the function the graph of this function is concave up. From here you can say that the point C is an inflection point. How we're gonna describe it? Yeah, there is a point of inflection mhm, on the graph of f of x at x equals minus 2, since um, the sign of the second derivative is changing at this point. Yeah. The next question, given that f of minus 2 equals 36, find f of x. Okay, we're gonna find the f of x. I know the first derivative of this function. Let's write it again. The first derivative is given that 3x squared plus 12x and 12x minus 15. So to find the f of x, we're gonna write the integral of this function 3x squared plus 12x minus 15, okay? It will be x to the power of 3, the integral of 3x squared, plus the derivative of 12x will be 12x squared divided by 2, the power of x, minus 15x plus c. Actually, it will give us the function f of x. And I know that at the point minus 2, the value is 36. So I will plug in minus 2 to the power of 3, plus we can cancel 2 in here. 6 times minus 2 squared minus 15 times minus 2 plus c will be 36. Yeah. Here is minus 8 plus 24 plus 30 plus c 36. And let's simplify here, and it will give us 46 plus c equals 36. C equals minus 10. In this case, we found f of x. F of x equals x to the power of 3 plus 6x squared minus 15x minus 10. Yeah, that's it. Question 10, consider the expression 1 over 1 plus x squared, where x absolute of x less than 1. Show that the first four terms in the binomial expansion of this expression are 1 minus x squared plus x to the power of 4 minus x to the power of 6. Yeah, we're gonna write the binomial expression of this expansion of this expression. 1 over 1 plus x squared equals 1 plus x squared to the power of minus 1. From here you can write the first term will be the 1, and the second term will be plus minus 1 times x squared divided by 1 factorial plus minus 1, and I'm decreasing this the power by 1. It's going to be minus 2 times x squared to the power of 2 divided by 2, right? And the last step will be minus 1 times minus 2 times minus 3 times x squared to the power of 3 divided by 3 factorial. Yeah, that's it. It's the same idea with the combination of this value. So when we simplify here, 1 is going to be minus x squared, and here is going to be positive sign, right? But we can cancel 2 in here, plus x to the power of 4. And the sign of this one will be minus, oh yeah, it's going to be minus x to the power of 6. And we can also cancel 3 factorial is 6 with the 6 at the denominator. So we show it at the first question. Yeah. And the second question of A is, hence find an approximation for the integral of this expression up to n, including the term in x to the power of 7. So when we find the integral of this, will give us the same, actually, the integral of the polynomial that we found in the previous question. Okay, we will find directly the integral of this expression, which is x minus 6 to the power of 3 divided by 3 plus 6 to the power of 5 divided by 5 minus 6 to the power of 7 divided by 7. You can add c, the constant value, okay? Now consider the expression, the square root of this, and expand this expression up to and including the term in x to the power of 4. Okay, we will now try to find this expression first. You can write this expression like 1 plus x squared to the power of minus 1 over 2, because I would like to write the reciprocal of this fraction. To do that, you will add the negative sign, and the square of this expression will give us divided by 2. So how we're going to write this the binomial expansion of this expression. The same idea, 1 plus minus 1 over 2 times x squared divided by 1 factorial 1 minus 2, I'm decreasing by 1. It's gonna be minus 3 over 2, right? Times x squared to the power of 2 divided by 2 factorial. And it say us that including the term in x to the power of 4. So I just stop it. And 1 will be minus x squared over 2, the middle term. And the last term will be, here is going to be positive sign, 3 over 8 times x to the power of 4, right? Uh, but here is gonna be minus, sorry, so I will change here. Okay, so this will be plus and the other one also, I guess, yeah. Okay, the next question, it asks for this integral. I will find the integral of this expression. So meaning you can find the integral of this polynomial instead, right? Okay. The integral of this polynomial will be x plus x to the power of 3 divided by 6. It's coming from the power and 2 here. Plus 3 over 8 times x to the power of 5 divided by 5. You can add c in here. And you can simplify x plus x to the power of 3 over 6 plus 3 times x to the power of 5 divided by 40. Okay? Yeah. The expression in here, this one, can be used to approximate arc sine 1 over 2. Use the result from part B2 to find the value of k. Okay, in this part, we know that actually the integral of this expression will give us arc sine. You can check from the formal booklet, okay? So we can directly to equate this the function to the expression that we found in the previous question here, right? In this case, I'm looking for arc sine 1 over 2. I will just replace 6 with 1 over 2. To do that, I'm just plugging 1 over 2 plus, I will write directly, if you don't mind, it's gonna be 1 over 48 plus 3 over 40 times 1 over 32. Just simplify here, and you can write the common multiple here for this two fraction, and it will give us 25 over 48 plus 3 over 1280, right? Yeah. So we found the value of k in here, the numerator of this fraction, k equal 3. Okay, the last question is find an approximation for pi in the form pi over 640. We know that arc sine 1 over 2 equal pi over 6. Why? Because sine pi over 6 equals 1 over 2. Yeah. If you would like to find the pi, and the pi will be 6 times arc sine 1 over 2, which means we can multiply by this 6 with 6, and we're gonna multiply by the expression that we found in here in the previous question. Okay, it is, you can cancel here or write first 6 times 25 divided by 48. Okay, and you can cancel 6 in here, 25 over 8 plus, let's cancel 2 in here, 9 over 640, and it asks for the denominator will be 640. With that, I will just write the common multiple here, we'll multiply it by 80, will be 2009 over 640. Yeah, that's it. So the value of P is 2009. Question 11. Consider the complex number W or I divided by 1 plus I square root of 3. Show that W equals square root of 3 plus I. Okay. Now we're gonna make denominator a real number. To do that, I will multiply the denominator with its conjugate. This is 1 minus I times square root of 3. Yeah, I multiply the fraction with this expression. So we will get 1 minus square root of 3. It's gonna be 3 times I square. In the numerator, we will get 4i minus 4i square root of 3, right? And denominator, I know that I square equals minus 1. In this case, there are 1 plus 3. So W will be 4i plus again, here is gonna be minus 1. So 4 square root of 3 divided by 4. If we cancel 4, we will get I plus square root of 3. Yeah. Find the magnitude of W. The magnitude of W is square of the real part plus square of the imaginary part, which is 1 in here. So this is square root of 3 plus 1, square root of 4 equal 2. The argument of W, you know that W equals square root of 3 plus 1 time I. And I can say that uh, tangent theta, this is the angle of this complex number, will be 1 over square root of 3, which is imaginary part divided by the real part. And it will give us, if we check for the inverse of tangent 1 over square root of 3, it will give us argument W, right? And I know that this angle is pi over 6. Yeah. Next question is use the Moivre theorem to find the two square roots of W. Give your answers in the form r times e to the power of I theta where r greater than 0 and theta between minus pi and pi. So let's write it first in the complex number in the polar form was that we found the magnitude of the complex number. This is 2 times e to the power of the argument of a complex number is pi over 6. So I will write I times pi over 6. Okay, this is the polar form. So to find the roots of this complex number, I will write the angle pi over 6 plus 2k pi because it's periodic and we can change k, and in this case the complex number will be, it will give us the same. But when we apply the De Moivre rule to find the roots of this complex number, is ask for square roots. In this case I will write square root of W, and it will be square root of 2 times e to the power of I times, and we will divide the angle by 2, okay? So we can write pi, or when you write the common multiple of this, pi plus 12k pi divided by 6, right? So the first complex number or roots come from here. If we assume or let that k equals 0, we will first find square root of 2 times e to the power of I times, uh, let me check it. I didn't divide it by 2, right? Yeah. Now we're gonna multiply it by 1 over 2. So in this case, the first root will be pi over 12, and the second root will be square root of 2 times e to the power of I times, when we let k equals 1, it will be 13 pi over 12, but we know that the angle of this complex number will be between minus pi and pi. In this case, we can write instead of this angle, when we subtract 2 pi from this angle, we're gonna get, let me write in here, 2 pi. You can subtract from this. It will be minus pi over 12, right? Yeah, this is the second root, or 11. Yeah, correct. Minus 11 pi over 12. The next question is the complex number w can be expressed in the form a plus bi square, where b is a positive real number. Show that a square equals square root of 3 over 2 plus 1. Okay, and if w equals a plus bi square, meaning w equals a plus bi square, we can say that square root of w will be a plus bi, right? Which from here we can say that z1 actually will be a plus bi, because these are the square roots of w, and we are already talking about this, okay? And we can say that in this case, a plus bi will be, let's say, square root of 2 times e to the power of I times pi over 12. So how are we gonna write this? I know that this is e to the power of I theta equals cosine theta plus I times sine theta. And if there is r, we can just multiply it by r. I will write it cosine pi over 12 plus I times sine pi over 12. Okay, and from here you can say that you already, the real part will be square root of 2 times cosine pi over 12, and the imaginary part will be square root of 2 times sine pi over 12. We are looking for square of these numbers. In the first question, for example, it asks for the a square and base b square. Okay, and let's find a square. A square will be 2 times cosine square at the point pi over 12. How we will get this? I know that the double angle property will be, if there is cosine pi over 6, we can write 2 times cosine square pi over 12 minus 1. Okay, from here you can say that cosine square pi over 12 will be cosine pi over 6 plus 1 divided by 2. We can replace this. In this case, we will write 2 times cosine pi over 6 plus 1 divided by 2, and we cancel 2. Cosine pi over 6 will be square root of 3 over 2, and that is plus 1. Yeah, we show it the first. And for the second question, we're gonna get now the square of b, which will give us 2 times again sine square pi over 12. And we will again apply the property of double angle of cosine. Was that the second property is with the function sine. Let me write it. Yeah, cosine pi over 6 will be 1 minus 2 times sine square pi over 12. And from here you can say b square equals 2 times, in parentheses, we can write directly. Let me check it. Cosine, yeah, it will be 1 minus cosine pi over 6. From here you can say that b square equals 2 times 1 minus cosine pi over 6 is square root of 3 over 2, and it is, let me check it again. Okay, there is no 2 in this case. Yeah, that's it. We found it. This is directly equal this. Okay. Yeah. The next question is, hence express tangent pi over 12 in the form. Okay. We find, I know that tangent pi over 12 equals sine pi over 12 divided by cosine pi over 12. And we found it, and we can, for example, write in here. I will write a bit down. We can say from here, for example, sine pi over 12 will be 1 minus cosine pi over 6 and divided by 2 square of this. In the same manner, I will write for the cosine pi over 12 we found in here. It's gonna be 1 plus cosine pi over 6 divided by 2. We found both of them. We can write in the same square root. And the first one will be, yeah, here. 1, we can cancel 1 over 2. 1 minus square root of 3 divided by 2. And the second one will be 1 plus square root of 3 divided by 2. Okay? And you can also simplify this square root of, let's say, 2 minus square root of 3 divided by 2 and 2 plus square root of 3 divided by 2, which will give us 2 minus square root of 3 divided by 2 plus square root of 3. And if we multiply the fraction by 2 minus square root of 3, we will see that we will get 2 minus square root of 3 because square of the square root of this expression, we can cancel the square root, and the denominator will be 1 because 4 minus 3 we will get. Okay, and this is 2 minus square root of 3. We get it. Yeah.
If you found this helpful, please support the channel by liking, sharing, and saving the video. Thank you for watching. Take care. Bye bye.